Hey, glad you could join us. It means a lot that you're here. We're about to go on a calm, beautiful journey through space, so I hope you found a cozy spot to settle in. Maybe you've dimmed the lights a bit, maybe you're curled up in bed, or watching the night sky through your window. Wherever you are, thanks for making space for this moment. I know life can be loud, so let's turn the volume down together. If you like listening to quiet stories about space and stars, please tap the like button. It helps others find this peaceful place too. And if you want to come back for more calm journeys through the universe, please like and subscribe. Enjoy what I do here, and let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Hey everyone, today we're looking into stars, but not just any stars. We're traveling far beyond the shining ones you might see outside your window tonight. We're diving into something deeper, darker, and far more mysterious. We're going to follow the story of what happens when two black holes, those quiet, invisible giants of space, finally find each other. Can you hear that? That's the hush of the void as we drift past a silent region of space. Not much light here, not much warmth either, just us and the soft hum of nothingness. But don't worry, even though it's dark, you're safe with me. We're just observing, floating. Now picture this. Far in the distance, a star once lived here. It burned brightly, danced with light, maybe even had planets swirling around it. But its time came to an end. The star ran out of fuel, and like a great breath exhaling its last, it collapsed in on itself. What was left behind? A black hole. Reach out, gently feel that pull. That's the gravity of it. It doesn't scream or glow. It doesn't sparkle. It simply waits. It's like a sinkhole in space. Anything that comes too close vanishes forever. Light, matter, even time, all disappear. Now we're moving. Slowly, steadily. Let's travel across the cosmic ocean. Ahead of us, another one just like the first. A second black hole. They've been alone for ages, maybe billions of years. But fate, as it often does out here, has different plans. Can you sense it? That slow movement. These two black holes are inching closer. Not quickly, not like fireworks or explosions. It's more like the rhythm of a tide, pulling gently, but with the weight of galaxies behind it. Let's hover between them for a while. On our left, the first black hole. It's about 10 times heavier than the Sun. On our right, its companion. This one's slightly smaller, but still a heavyweight in its own right. Neither makes a sound. There's no wind here, no up or down, just space, wrapped around them like a still ocean. You might notice the space around them isn't calm though. It bends, it curves, it twists slightly, like ripples in a clear pond. These are signs, gentle clues that something powerful is happening here. Even before they meet, the black holes are affecting everything nearby. They're changing the very shape of the space between them. Drift a little closer. Do you feel that? A kind of stretching sensation. Not painful, just odd. Time moves strangely here. Clocks don't tick the same way. If we had a wristwatch, it'd slow down, ever so slightly. That's what black holes do. They warp time itself. Now look at the space between them. It's shrinking. They're drawing nearer, orbiting one another in a slow, invisible dance. At first, they were far apart, but gravity is patient. It's been pulling them together for a long time, millions of years, maybe longer. Every loop they make around each other releases tiny waves. Not sound waves. These are waves in space itself, gravitational waves, quiet but powerful. They ripple out, like a soft drumbeat through the fabric of the cosmos. You can't hear them, but they're there, passing through galaxies, moving through planets, even brushing past you as you sit and listen. Imagine holding your hand out. If we had the right kind of instrument, something sensitive enough, we'd feel a tiny tap. That's a wave from this black hole dance reaching us, after traveling across the universe. And now the orbit tightens. You can see it, right? They're spinning faster, closer. What was once a long, lazy loop is now a tight spiral, like two skaters drawing into a spin. The energy is building. Stay with me. We're at a special moment now. It's the final seconds. The black holes are only a few kilometers apart, closer than 2 city blocks, yet each one still weighs more than entire clusters of stars. Then it happens. Not an explosion, not a flash, but a collision of darkness. Two silent giants fold into each other. Space bends wildly. Time twists. Gravity surges like a drumbeat. And for a moment, the universe sings in silence. Feel that? That low, almost imperceptible thrum? That's the aftermath. One single, larger black hole now floats where two once were. It's heavier, quieter, but still hungry, still waiting. All around, the space is calming again, like waves settling after a stone has dropped into a pond. Let's float here a bit longer. The light nearby flickers gently. Stars in the far distance shimmer like tiny fireflies. Some may have felt the ripple from that cosmic collision. Others are too far away to notice. But you and I? We were here. We witnessed it. And it's not the only one. These collisions happen more often than you'd think. Quiet, invisible meetings in the darkest corners of space, each one shaping the universe in small but powerful ways. So, how does something like this begin? Picture yourself in a quiet patch of space. Not much going on here at first glance. But now look deeper. Zoom into one of those old galaxies, the ones that formed billions of years ago, when the universe was still young, still experimenting. In one of its spiral arms, two stars are born. Can you see them now? Bright, blazing, beautiful giants, bigger than anything in our own solar system. One of them is maybe 30 times the mass of our sun, the other, maybe 25. These stars are massive, and because of that, they live fast and burn hard. They don't twinkle, they roar. Imagine them as great cosmic bonfires, throwing off winds and flares the size of planets. Their light pushes back the darkness for light years around. And the best part? They're not alone. These two stars were born as a pair, a binary system. Think of them orbiting each other like twin dancers, locked in a rhythm that's been going for millions of years. Round and round they go, spinning in harmony, wrapped in each other's gravity. Now, zoom ahead a few million years. It doesn't sound like much out here, but that's a whole lifetime for a star this big. The first one, the heavier one, starts to wobble. You see that shimmer in its surface? That's instability. It's nearing the end. Its core runs out of fuel. The light flickers, the outer layers shudder, and then, boom. But not the kind of boom you might expect. There's no fireball in the sky, no cinematic explosion. Instead, the core collapses inward at breathtaking speed. Gravity takes over. The entire heart of the star implodes. In a heartbeat, the mass is crushed into a single invisible point. A black hole is born. The outer layers might burst outward in a shockwave, a supernova, but at the center, there's now only darkness. You might feel a pull, just a little one, gentle but inescapable. This black hole, still hot and spinning, sits right beside its still living companion. That second star keeps orbiting, maybe unaware that its partner is no longer shining. Fast forward again. The second star ages too. It puffs up. Its surface boils. It throws out powerful winds. Some of that material might spiral toward the black hole, glowing brightly as it vanishes into the invisible. You can almost hear the whisper of it being devoured. Then, eventually, the second star dies in the same way. A final collapse, a last breath, and then another black hole. Now we have two. They're close, closer than most ever get. Their orbits are tight, their gravity locked together like chains. They spin, they pull, and over time they begin to fall inward. But why? Because they're leaking something. Not air or sound, remember. There's none of that here. They're releasing energy in a strange, invisible way. Every twist of their orbit sends out those gentle gravitational waves like quiet sighs into the fabric of the universe. Each wave steals just a little energy. Not much, not at first, but enough. The black holes get closer, their orbits shrink. Round and round they go, like two dancers circling tighter and tighter. The speed increases. Time ticks strangely here. If you were nearby, if you could somehow watch, you'd see them begin to blur together. Let's move closer. You and I are weightless here, just floating, just observing. You might hear something in your imagination now, not sound in the usual sense, but more of a rising hum in your mind. A deep cosmic tone that rises as they approach. Their final spiral is like a heartbeat speeding up. 3, 2, 1. And just like we saw before, they merge. The process takes less than a second, but the journey? That took billions of years. A story written in gravity, silence, and time. So when we ask, how do two black holes collide? That's the answer. It starts with stars, with light, with a pair of giants being born side by side. Then comes collapse, gravity, and a spiral that never ends until they become one. But even now, our journey isn't over. There's more to see. What happens after the collision. What's left behind? How do scientists here on Earth detect such a quiet, distant event? And what do these collisions tell us about the universe itself? Still curious? Good, because we're just getting started. The moment after the collision is surprisingly calm. There's no explosion, no flames, no wreckage, just silence. Deep, dark, echoing silence. The two black holes have vanished into each other, and in their place is something new. Let your eyes adjust to this stillness. Right in front of us now is a single, larger black hole. Heavy, quiet, smooth and powerful in a way that doesn't shout. It just is. If you reach out in your imagination, you might feel a kind of hum, deep beneath everything. That's the echo of what just happened, the waves in space still moving outward, still stretching and squeezing the fabric of the universe as they go. Like rings rippling across a pond after a pebble has been tossed in. Except this pond is the size of everything, and the ripples move at the speed of light. Now, let's watch those waves move outward. They don't glow, they don't leave behind a trail, but they pass through everything. Planets, stars, even you and me. We're so small compared to the scale of this, but those waves gently pass through us all the time like tiny, cosmic handshakes we can't feel without the right kind of listening device. And speaking of listening, far, far away, imagine a small blue planet, not too different from ours. Scientists there have been waiting for something like this. They built special instruments, big, quiet ones, spread out across the land, listening for vibrations not in the air, but in the ground itself. These instruments can detect changes smaller than the width of a single atom, and suddenly, they hear it. A chirp. That's what it sounds like when you turn gravitational waves into sound. A soft, rising tone, like a bird's call from the end of the universe, just for a moment, and then silence again. It's hard to believe, but that little chirp tells them everything. It says, two black holes collided. It says, here's how heavy they were, how fast they spun, how far away it happened, and even when. Imagine being one of those scientists. You're sitting in front of a screen, numbers scroll past, and suddenly, the data lights up. You know that you're seeing something that happened more than 1 billion years ago, but the signal has only just reached Earth. And now, we know it happened. Back here, drifting beside the newborn black hole, we can see what they can only guess. The new black hole is spinning, fast, almost at the limit of what's possible. It's smooth as anything can be in nature. No edges, no lumps, no scars from the collision. Just a perfect, invisible sphere where time slows and light disappears. You might feel a little awe here. It's okay. This place, this very moment, is a kind of grave and a kind of birth all at once. The two original black holes are gone. But their gravity, their spin, their story, that lives on in this single, larger black hole. Now look around again. The space nearby is still bent, still twisted slightly, like the air over hot pavement, but it's settling. The wild curves of space from a few seconds ago are relaxing, smoothing out. The energy has been spent, the ripples are fading, balance is returning. Let's float a little farther back and look at this scene from a distance. What do we see? Well, not much if we're being honest. From far away, a black hole looks like nothing at all. It doesn't shine, it doesn't glow. Unless there's something nearby for it to feed on, it remains perfectly silent, perfectly dark. But we know it's there. We felt it. We saw the story unfold. We know that here, just moments ago, something incredible happened. And this is one of the strangest truths about the universe. Some of its most powerful moments leave behind almost no trace, no fireworks, no noise, just a faint signature, a tiny whisper in space, a ripple on a detector, and a bigger, heavier black hole continuing the story. Sometimes, not always, but sometimes the new black hole will be kicked. Yes, kicked. Not like a soccer ball exactly, but imagine this. The two original black holes didn't spiral in perfect symmetry. Maybe one was spinning faster. Maybe they weren't quite lined up. So when they merged, the new black hole got a little push, a recoil. It might fly off at hundreds, or even thousands, of kilometers per second. That's fast enough to escape entire galaxies. Imagine a black hole, formed in a quiet corner of a galaxy, suddenly flung outward like a cosmic cannonball. It moves through space, with nothing to slow it down. No atmosphere, no friction, just endless silence, and the invisible trail it leaves in gravity. Let's follow one of those. Out here, this rogue black hole is flying silently through intergalactic space. No light shines on it. No one sees it pass. But maybe one day, far in the future, it will pass close to another star. It might tug on it. It might even steal it. That star could start to orbit the black hole, spiraling in slowly, until its light, too, is swallowed. And just like that, the cycle begins again. So what happens after two black holes collide? A new black hole is born. The universe changes not loudly, but deeply. A signal travels across time and space. Scientists detect it. They celebrate. They update what we know. And somewhere, silently, gravity keeps pulling, stars keep burning, and the dance continues. How do we even know any of this? How can creatures like us, small, soft, living on a tiny blue dot, even detect these distant dances of darkness and understand the signals they leave behind? How do we listen to something that doesn't make sound and watch something that doesn't shine? How do we catch a whisper from billions of light years away when it doesn't pass through air or light or time the way we're used to? How did we ever find out that two black holes were spinning and falling and merging somewhere out in the deep? Well, imagine a wide, flat place on Earth, maybe a quiet countryside, or a long stretch of desert. No traffic, no towers, just space and silence. And in that silence, humans built something beautiful. Not to see stars with lenses, but to feel space itself move. A giant pair of arms stretching across the land, each 1 kilometers long, with lasers bouncing back and forth in perfect stillness, waiting for something that might never come, watching space with a kind of patience that only gravity understands. Then one day, very faint, a ripple passes through, stretching one arm just a little more than the other, not enough for a human to feel, not even enough for a speck of dust to notice, but enough for the lasers to blink, for the detectors to whisper to the scientists. Something has passed through, something from far away, and that something is a wave, not made of light or air, but of space itself stretching and squeezing as it moves. And we turn that wave into a sound, a chirp, short and rising, like a tiny song from the universe. And inside that chirp we find a message. We learn how heavy the black holes were, how fast they danced, how far away they lived, how long they circled each other before they finally touched. It's strange to think that so much truth came from something we didn't see. No explosion, no flash, just a change in distance smaller than an atom. But that's how the universe talks when it wants to speak softly. And we were listening. We may be small, soft, held tight by gravity on a world spinning around a sun that itself spins through a galaxy. But somehow, we built ears big enough to hear black holes collide. And that's how we know. But how does time behave when these giants come close? Does it stretch and slow? Or does it twist in ways we can barely imagine? Picture yourself drifting slowly, weightlessly, between these two colossal black holes as they spiral ever closer together. Around you, space is quiet, but something else is happening. Something invisible, something that bends the very fabric of existence. Time itself begins to change. You might think of time like a steady river, flowing smoothly, carrying everything from moments to memories along with it. But near these black holes, that river is no longer calm. Instead, it becomes wild and strange. Imagine that river suddenly hitting a rocky canyon, where the water slows and pools in quiet eddies, only to rush forward in a burst just beyond your sight. Here, time pools and stretches, moments dragging out like slow-motion scenes in a movie, every second thick and full. Your heartbeat lingers, your breath deepens, and the simplest flicker of thought seems to hover, like a bubble floating suspended in the air. At the same time, look out beyond the black holes, and time might be speeding up, racing along like a wild stallion you can't quite catch. Events that seem paused to you might be flashing by in an instant somewhere else. It's as if these black holes, these giant dancers of gravity, are not only pulling space toward them but also tugging at time itself, reshaping it as if it were soft clay in their powerful grip. Now imagine that time does not just slow and speed up, but also folds and twists. Think of a ribbon you've been playing with, twisting it, looping it around itself until it forms knots. That's how time behaves here. Near the edges of these black holes, time might bend back on itself, creating loops where the past, present, and future swirl together, indistinguishable. A moment might repeat like a whispered echo, or stretch so long it feels like forever. You might catch glimpses of what was, what is, and what could be, all tangled together in a quiet, cosmic dance. This twisting of time isn't just something to imagine, it's written into the very rules that govern our universe, the laws that these black holes follow as they spiral and collide. Scientists have learned that near these massive objects, time doesn't tick like the clock on your wall. It slows down more and more the closer you get to the edge of the event horizon where even light cannot escape. If you were watching someone fall toward this edge, their movements would seem to slow until they almost freeze in time, stuck in an eternal moment, as seen from far away. But for the one falling, time would seem normal, flowing like always, a strange difference between two perspectives that stretches the mind and challenges everything we think about reality. It's like watching a movie where two screens show the same scene but at wildly different speeds, both real, both true, but impossible to fully grasp at once. Now, with two black holes dancing near each other, this effect becomes even more strange and complex. Their massive gravities weave together, creating a gravitational ballet that folds and stretches time around them in ways that even the smartest minds still puzzle over. The space between them, once calm and empty, becomes a dynamic stage where time flows unevenly, sometimes almost stopping, sometimes rushing ahead. Imagine standing there in that space, your own sense of time becoming fluid, a strange sensation that pulls you out of the usual rhythm of life. You feel like a traveler caught between different moments, a passenger on a ship sailing through currents of time that ebb and flow unpredictably. One breath could last minutes, and in the next instant, a whole day could flash past like a quick blink. It's disorienting and beautiful, terrifying and wondrous all at once. And yet, amid this wild behavior of time, there is a strange kind of harmony. The two black holes continue their dance, spiraling closer, with a rhythm that is both chaotic and precise. Their collision will change the very structure of space and time, sending ripples across the universe, waves that will carry the story of their meeting across billions of light years until those signals reach us, tiny creatures on a tiny blue dot, and whisper to us the secrets of time itself bending and twisting near these giants. But what if two black holes collide, but don't merge? Not in theory, but here, right now, you and me, floating together at the edge of that moment. So, picture it. We're drifting silently through the velvet dark, past the cold breath of distant nebulae and the glowing arcs of newborn stars. We're guided only by a faint tug, almost like being reeled in by a cosmic current. And then, there they are, two black holes, enormous, ancient, spinning, on a collision course. But something strange happens. They don't crash into each other like boulders. They don't fuse into one bigger monster the way we sometimes hear about. Instead, they pass. They graze each other in a furious, violent swoop, but they keep going. And here's where it gets wild. Sometimes, when two black holes meet, they can bounce off each other. Not because they have hard surfaces, they don't, but because their gravitational pulls are so intense, and the angles of their encounter so specific, that one of them can slingshot the other away. Or they both can spiral off in new directions, like dancers caught in a missed step. You might be thinking, how is that even possible? Well, it's all about momentum and direction. If they're moving fast enough, and not perfectly lined up, the collision doesn't end in a smooth merger. Instead, space itself stretches and snaps around them, flinging them apart like stones tossed in a pond that briefly ripple into each other, then keep moving. Sometimes they don't escape entirely. They loop back, caught in each other's gravity. That's when they form what scientists call a binary black hole system locked in orbit, like two massive shadows forever chasing one another. Other times, one black hole might get flung into deep space at incredible speeds. We're talking millions of miles per hour, fast enough to leave its galaxy entirely, a runaway black hole. Imagine that, a rogue black hole, screaming through the void, utterly invisible, unless it swallows something unlucky enough to drift into its path. And meanwhile, the other black hole, the one that stays behind, might wobble, spinning strangely for a while. It might settle, it might not. The balance of the universe disturbed by just that almost collision. So, what happens when they don't merge? Chaos, orbits distorted, gravitational waves ripple outward, even from a near miss. Stars nearby might shift subtly, tugged this way or that. Planets might be thrown from their suns. The very fabric of space flexes, then settles, like a great breath held, then exhaled. And here's the wildest part. Some theories suggest that when two black holes nearly collide but miss, they might eventually merge later, but the delay could take billions of years. They might drift for ages before spiraling back toward that final, true embrace. Or maybe something else interrupts. Another black hole joins in, a third dancer, and now the whole ballet changes. So you see, just because they don't merge now, doesn't mean their story is over. It might just be beginning. We're still out here, floating in that quiet, star-flecked darkness. The two black holes from before are still locked in their fierce orbit, whirling endlessly like titans circling a promise they haven't yet fulfilled. Each loop brings them dangerously close. Each pass sends out those deep, trembling gravitational waves, but they haven't merged. Not yet. Now, let your mind stretch a little farther, past the twin giants, past their invisible wake. Out there you feel it, a third pull, subtle but unmistakable. A third black hole is drifting closer. It's smaller than the other two, at least in mass, but it's no less mysterious. It's older, maybe, quieter. It doesn't blaze with falling matter. It's cold, calm, moving with eerie precision, and it's heading straight into this cosmic dance. Now, what happens when a third black hole enters the scene? Everything changes. Imagine tossing a third ball into a game of catch between two people. The rhythm breaks. The pattern becomes unpredictable. Things get chaotic fast. But this isn't just a game, this is space being pulled in three directions by monsters that don't play fair. Here's what we see. The smaller black hole starts to tug gently on the others. At first, the effect is minor, a slight wobble, a drift in orbit, but gravity doesn't whisper forever, it builds. It's patient, and soon, that third black hole's presence starts to unravel the delicate orbit the first two had maintained for eons. You and I float back a little, just enough to watch without being noticed by the cosmos. Now look, you'll see the original pair begin to spiral erratically. One might swing out wider than before, the other pulls tighter. The timing is off now, the rhythm broken. And the newcomer? It circles from a distance like a silent observer, but its influence is growing. Sometimes, this third black hole gets caught. It joins the dance. The three of them twist and reel around one another in a dizzying cosmic spiral, a triplet bound not by ropes, but by warps in space-time itself. Other times, things get violent. The gravitational chaos can reach a point where one black hole, often the smallest, is flung outward like a slingshot. Imagine being launched from a cosmic merry-go-round at such speed that you never return. That black hole becomes a rogue, wandering the universe alone. No light, no orbit, just drifting in silence. Now picture this. The two remaining black holes, relieved of that extra gravitational stress, might finally merge. A huge, sudden collision. Matter crunched. Waves of energy rippling out at the speed of light. A new black hole is born, more massive than either of the originals, spinning wildly with the energy of their final embrace. Or maybe not. Maybe the presence of the third black hole destabilizes everything permanently. None of them merge. They just keep swinging past one another in erratic, unpredictable loops. Each encounter warps the next. The system becomes what we call chaotic. Not just complicated, truly unpredictable. Tiny changes in their orbits lead to vast, untraceable differences over time. It's like the universe is rolling dice with giants. Now feel the space around us. Notice how uneven it feels. That's the gravitational landscape. Warped, twisted, torn slightly, in 3 directions at once. It's not something you see. It's something you feel like pressure in your ears before a storm, or the way your stomach drops on a roller coaster. Reality itself is bent here. If there are stars nearby, they might get caught in this game too. A passing star could be yanked from its orbit, tossed into a loop, or even swallowed whole. A planet maybe once home to life might be slung into cold, deep space. A moon might be flung into its sun. A dust ring might collapse. This is cosmic reshuffling, galactic dominoes. And we're lucky. We're just observers. Now here's a fun thought. Sometimes, the 3 black holes settle into a stable triangle, an orbital pattern so rare, so delicate. It's like finding a snowflake balanced on a volcano. If they fall into just the right timing, each one can follow the other in a perfect cycle, moving forever in a kind of silent harmony. But don't hold your breath. That outcome is rare, astonishingly rare. It's more likely that the system breaks apart. Sometimes, 2 merge and the 3rd flees. Sometimes, the 3rd interrupts a merger and causes all 3 to fly off in different directions, never to meet again. And here's the kicker. We know this can happen. In distant galaxies, we've spotted systems where 3 supermassive black holes are circling each other near the center leftovers of ancient galaxy collisions. They're not myths. They're real. And they're just far enough away that we get to watch them slowly, curiously, without fear. Reach out now. Just a hand, slowly. Feel that pull? The 3rd black hole is getting closer to the pair. Not fast, but with purpose. You can sense it, can't you? The tension growing. The space between them contracting. We can't stop it. We can only bear witness. So let's wait. Let's drift quietly on this edge. Eyes open, hearts still. Because when 3 black holes meet, the universe doesn't roar. It tightens, it bends, it changes, and afterward, nothing is quite the same. Now let's ask, what if 2 supermassive black holes collided at the center of a galaxy? Hold on to that thought as we begin to travel not quickly, but steadily, through clouds of gas and ribbons of stars, past pulsars ticking like ancient clocks, past drifting planets and quiet moons. Ahead of us is something colossal, not just big, fundamental. We're approaching the center of a galaxy, not the kind of center you draw on a map, the true core, the gravitational anchor, the heart that everything else spins around. And nestled deep within it, sometimes hidden behind clouds of dust and light, is a supermassive black hole, one of the largest things that can exist, not the size of a city, not even the size of a star. These things can be as big as an entire solar system, millions, sometimes billions of times the mass of our sun. But wait, something's different this time. There's not just one, there are 2, and they're closing in on each other. Let's hang back a little, watch from a respectful distance. We're witnessing a collision of giants. You might be wondering, how do 2 such monsters end up in the same place? Galaxies collide. Not suddenly, like crashing cars. No, galaxies drift together slowly, drawn by gravity over billions of years. And when they finally meet, their stars mostly pass through each other like ghosts. But their black holes, the ones buried in each galactic core, they're not so gentle. They fall inward. They spiral together. They collide. And what happens next? Let's look. At first, it's quiet. You'd think something this big would explode in a flash, but black holes don't explode. They swallow. They bend. They reshape everything around them. So the first sign isn't fire. It's motion. Gas clouds whip into frenzy. Stars near the center get slung into new orbits. Whole solar systems are disturbed. And between the 2 black holes, matter starts to swirl violently, chaotically, glowing hot as it falls in. The core of the galaxy becomes a storm, brighter than anything for millions of light years. And as the black holes spiral closer, something incredible happens. Gravitational waves, enormous, slow ripples in the very structure of space, begin to roll out from the center. These aren't the tiny tremors we felt before. These are tsunamis of gravity. If you could stand still in deep space and feel them pass, it would be like time itself stretching and compressing in slow, impossible pulses. You and I, floating here on the edge of this galactic core, can feel them like bass in your chest at a concert not heard, but known. And then, the moment comes. The final merge. The two supermassive black holes touch. But again, there's no explosion, no crack of light. Instead, a kind of silence, a blink in space, a reshaping of the invisible. They collapse into each other, forming one even larger black hole, heavier, more powerful, spinning faster than before. Matter that was caught between them vanishes. The accretion disk flares. Jets of energy, actual jets, brighter than entire galaxies, may fire out from the poles for thousands of light years. They can last for millions of years. You can even see them from Earth. These are quasars, the brightest objects in the universe, powered by black hole mergers, just like this. Now breathe with me, gently. Take in the aftermath. The center of the galaxy is different now. The stars around it move to new rhythms. The gravitational landscape is rewritten. The core spins faster. Any nearby black holes? They're drawn in slowly. Planets that once might have known life may now orbit nothing. You might wonder, does this destroy the galaxy? No. The galaxy survives, but it changes, like a tree hit by lightning, not gone, but forever marked. And the new black hole? It rests, quiet for now, but patient, always patient. Now consider this. These mergers shape the universe. They're part of how galaxies grow. Part of why our Milky Way will one day merge with Andromeda. And yes, when that happens, our own black hole will likely meet Andromeda's. Will we see it? Maybe not. But it's happening even now, all over the cosmos. We've already seen what happens when a third black hole stirs the pot, and when supermassive black holes collide at the core of galaxies. So now, let's stay with our two colliding black holes, but explore what unfolds in the moments after they finally merge. Come with me. Let's drift closer again, just enough to watch, not enough to fall. That's the rule out here. The black holes have just collided. Their final orbits were tight, fast, vicious, like two whirlpools slamming together. No light was emitted from the collision itself. Black holes don't shine. But all around them, space shook. A ripple like no other spread outward. Gravitational waves. Yes, but now, they're not just waves. They're echoes of the moment. The universe bent. But now, something strange happens. The new black hole, the one formed from the collision, isn't stable yet. Not immediately. It wobbles. Yes, imagine that. Even this enormous, newly formed black hole isn't perfectly still. It vibrates. Its shape flickers for a moment, like a jelly settling after a drop. Scientists call this the ring-down phase. But forget the name. Just listen. You might even feel it in your chest, that deep, slow thrum, a final hum as space relaxes. And then, stillness. Total, eerie stillness. There's no explosion, no flash, but something has changed. A new black hole is here now. Bigger, heavier. It might spin fast too, faster than the two before. Because when black holes merge, they don't just add their masses, they add their momentum. That spin can twist the space around it, literally dragging space-time in circles near its event horizon. Now imagine being near it. Not too near, of course, but just on the edge. Look around. You'll notice something subtle. The stars behind the black hole there, warped, distorted, curved into loops and rings. That's not an illusion. That's gravity bending light itself. This newly formed black hole is so massive, so intense, that it's acting like a lens, a natural one. You and I are seeing the universe doubled, mirrored, stretched around the edges. This effect has a name too, gravitational lensing. But again, ignore the labels. Just let yourself see it, feel it. This is the universe letting us peek behind the curtain, showing us how strange and wonderful things become when gravity takes control. Now, here's something curious. After the merger, this new black hole might not stay still. The final collision can give it a kick, a sudden, powerful shove, not with hands or explosions, but with momentum. All that swirling mass crashing together doesn't always balance out evenly. So the result? The black hole gets launched. Yes, picture that. A black hole the size of a solar system, moving, not floating, firing off, like a cannonball in slow motion. Sometimes the kick is small, just a little wobble, but sometimes it's enormous. If the kick is powerful enough, it could send this black hole flying out of its galaxy, not metaphorically, literally. It could escape the entire pull of billions of stars and go drifting through the void between galaxies, alone, cold, silent, invisible, a cosmic exile. And what does it take with it? Memories, perhaps, leftover gas from the merger, maybe even some unlucky stars that got too close, caught in its gravitational net like dust on a coat. Back near the galaxy it left behind, the core is changed, quieter, unsettled. The supermassive center is gone. Over time, stars might shift, orbits might drift. Whole regions of the galaxy might grow dark without their central anchor. And all because two black holes met and became one. Let's drift with it now, just for a moment. Watch as this new black hole, fresh from the chaos of collision, slides silently through the cosmos. No light, no trail, but still pulling, still shaping, still felt. Somewhere, in the far future, it may find something new to consume. A gas cloud, a star, a wandering neutron core, or another black hole, and the whole thing could begin again. Now let's ask ourselves, could two black holes actually start another Big Bang? It's a big question, maybe the biggest question, and to even wonder about it, we need to let go of what we think we know. Set aside our clocks, our calendars, even our idea of before and after. Out here, near black holes, time bends anyway. So let's imagine. Float with me now, way beyond the familiar, past galaxies, past the edge of the observable universe, past even the noise of background radiation, into a place or maybe a moment where things are collapsing inward, where the universe, instead of expanding, is shrinking, quietly, slowly, everything we've ever known, folding in. In this corner of thought, two black holes approach one another. But these aren't ordinary black holes. They're huge. Maybe the result of countless mergers. Maybe the final leftovers of stars and galaxies long gone. We don't know how they got here, only that they're all that's left. And now, they're drawing together. Their pull is overwhelming. Space itself seems to lean toward them. Time flickers. They move with the heavy inevitability of the tide. And then, they collide. But not like before. This isn't a cosmic crash like we've seen. This is everything, pulled into one point. The gravity is so immense, so perfect, so impossibly concentrated, that it becomes something else. Something we don't have words for. A place where time ends or maybe begins. And this is where the question comes in. Could this be it? Could this moment, this collision of ultimate gravity and matter, spark another Big Bang? We don't know for sure, but here's what we can imagine. Some theories say the universe might work in cycles, expanding, collapsing, and then rebirthing itself again. They call it a big bounce. In that idea, the collapse of everything, maybe even into a pair of colliding black holes, could become the seed of a brand new universe. A new explosion, a new expansion, a new time. In that sense, maybe those two black holes don't just end something. Maybe they begin something else. Maybe the birth of our universe, the Big Bang we came from, didn't come from nothing. Maybe it came from something like this. A universe before ours, shrinking down, winding up, spinning toward one last gravitational event, one final embrace between two black holes. And then, light. Not fire, not destruction, creation. Everything we see now, stars, planets, oceans, thought all from that single moment. A moment that, in some ancient space long before ours, might have looked just like this one. Two giants circling, spiraling, colliding, and maybe one day, billions of years from now, it will happen again. Now drift here with me, in the stillness, in the maybe. We don't need all the answers. The beauty is in the wondering, in looking at two black holes and asking not just how do they end things, but what might they begin? Close your eyes for a moment, if you want. Let the hush settle in around you. Feel the weight of it, this space between everything. We're floating now, not just through distance, but through time, through questions, through the kind of silence that feels sacred. The two black holes have collided, not in a burst of sound or flame, but in a quiet, infinite surrender. They've wrapped around each other like threads twisting into a single knot, tighter than anything else in existence. There's no light, no heat, only gravity, pressing in from all sides, folding, curling, compressing. Now imagine being close, not dangerously close, but just near enough to feel the pull on your thoughts, on your sense of when you are. Out here, seconds stretch, hours fold. We've drifted into a realm where cause and effect start to blur, where before and after are soft suggestions, not rules. And right here, right now, in this perfect, silent point where the two black holes have become one, something extraordinary begins to happen. Everything falls inward. Not just gas and dust, not just starlight. Everything, the very laws that govern the universe outside this moment, start to crack around the edges. Physics, time, light, they start to twitch. Like paper caught in a strong wind. It's not chaos, not yet, but it's not order either. It's transition. And maybe, just maybe, this is where universes are born. We don't know what's on the inside of a black hole. Not really. The edge, the event horizon, is like a locked door we can never peek behind. But some say that once everything falls past that point, the rules change. Maybe it doesn't crush into nothing, maybe it folds through. Now reach your hand out, not to touch, but to feel. Let your fingers trace the curvature of space here. The pull is steady, but different. It's directional, like a river forming from pressure. A funnel, not a pit. And here's a wild thought. What if the singularity, the point at the center of this merged black hole, isn't an end at all? What if it's a portal, a seed? Some theories say our own universe may have been born inside a black hole, that what we call the Big Bang was really the interior of some massive collapse in another reality. That time, space, and matter were squeezed so tight, so hot, so dense, that they bounced back out in a brand new expansion. And that's what we see now, in our own skies. Galaxies rushing away from each other, stars birthing stars, life appearing in brief, beautiful flickers, all the result of that single, unfathomable moment. What if we're watching it happen again? Look around you. The walls of the black hole, if you could call them that, are warping. Not in, but out. The pressure has grown too great. The collapse has reached its peak. And now, a flash. But not a flash of light, a flash of existence. A new universe is born. But you and I, we're not in it. We're just outside, watching the moment, like shadows behind glass. It unfolds impossibly fast. Space itself unrolls. Time begins to tick. From a single point comes distance, heat, light, the fingerprints of a brand new beginning. We feel the wave of it not against our skin, but against our understanding. Like a memory you can't quite place, but feels deeply familiar. A Big Bang, born from the quiet embrace of two black holes. Now breathe, slow, let that settle in. Two monsters, circling in the dark, may have lit the match that becomes everything. Maybe this isn't rare. Maybe this happens again and again, a universe behind every black hole, a hidden world in every final collapse. Maybe the stars above us aren't just stars, maybe they're history, told through gravity and heat. And maybe one day, our own black hole at the center of the Milky Way will be part of something like this. Maybe, in the end, all things spiral inward, not to die, but to begin again. Take a breath. Let the last bits of starlight slip behind us. The universe fades into shadow as we begin our next journey, the most mysterious one yet. We're going inside a black hole. I know, it sounds impossible, and in many ways it is. This isn't something we survive in the usual sense. But for now, just let yourself float, gently, like a thought that hasn't fully formed yet. Ahead of us is the event horizon, the black hole's edge. Not a wall, not a surface, but a point of no return. Once something passes this invisible boundary, it's gone. No light escapes. No signals return. It's as if the universe turns its back. And yet, here we are. You might notice that everything around us has gone strangely quiet. Not just silent quiet, as if even the background hum of space has held its breath. Stars behind us begin to stretch, blur, flicker, not because they're moving, but because we are. Our sense of time is changing, slowing, warping. One more step. And now, we cross the horizon. Surprisingly, nothing dramatic happens, not at first. There's no flash, no crunch. The boundary doesn't feel like a threshold. It's like walking through mist, familiar for a moment. Then, different. We're falling now. Not down, inward, but in a black hole inward doesn't mean what it used to. Inside this place, all directions lead to the center. There's no turning back, no sideways step. The very geometry of space has changed. It folds around us, gently, endlessly. Now, picture yourself drifting through this space. You're weightless, but the pull is still there. You feel it in your bones, not pain, not pressure, but inevitability. The same way leaves fall in autumn, or the tide returns to shore. Look out, and you'll see something extraordinary. Matter is suspended here. Gas, light, dust, even broken pieces of stars all caught in this cosmic descent, spiraling like fireflies in syrup, sometimes glowing, sometimes silent. Time is strange in here. For us, it's passing, but for the outside world, we've slowed to near stillness. And now, a question presses at the edge of thought. What's at the center? The truth is, we don't know. No one does. But there are ideas. Some say it's a singularity, a point of infinite density, where all the matter the black hole has ever swallowed is crushed into something smaller than a grain of sand. The laws of physics, as we understand them, simply stop working there. It's the heart of mystery itself. But others imagine something else. Not a point, but a bridge. A wormhole, maybe. A tunnel to somewhere new. Not science fiction, but a real, though still unproven, solution to equations we trust. If that's true, then maybe, just maybe, falling into a black hole doesn't mean an ending. Maybe it's a passage. To what? A parallel universe, a mirror reality, a newborn cosmos just beginning to expand? We don't know. But isn't it beautiful to wonder? Reach out with me, just your hand. Let it drift through the strange light that clings to the matter falling with us. It feels thick, warm even, like the air before a summer storm. We're falling faster now. Not because we're being pulled, but because there's no other option. Everything here falls, even light. The closer we get to the center, the weirder things become. Space isn't flat here, it curves. It pulses. It flows. Time, too, starts to feel more like distance. You might feel memories stretch long, emotions deepen. The past feels like it's happening now, and the future, it glows faintly, just out of reach. We might be the last witnesses to what this black hole has become. And if this black hole connects to something else, if it's a seed for a new universe, like we imagined earlier, then this fall is not a fall at all. It's a journey forward. We're not moving toward an end. We're sliding into a beginning, a place where the rules are brand new, a place where matter, energy, and time are being written again from scratch. Look, can you see it? Far ahead, beyond the warping light, there's something glowing. Softly, not bright, but steady, like the first star in a new sky. Maybe it's not real, or maybe it's the birth of something vast. Either way, we're almost there. Let's float toward it together, quiet as a thought. No fear, just curiosity. Because whatever comes next, it's a story we've never heard before. Let's stay calm, no rush, just breathe, if breathing still makes sense here. Everything feels stretched, doesn't it? Like time has softened. Reality is no longer a steady floor under our feet, it feels more like liquid now. And space doesn't point in directions anymore. There's no up, no down, no east, no edge. Just toward the center. But not just one center, two. That's where things get strange even for this place. These aren't two ordinary black holes circling, merging outside in the starry sky. We're within them. Already past their event horizons, already past the last gasp of light. And now, as they draw into each other, the inside the place we thought we understood even a little begins to shift in ways no human has ever seen. Imagine two worlds without surface, two infinite wells without bottom, folding into one another. The spaces they contained begin to mix, like water and ink, like dreams and memories. Their gravitational hearts spiral closer, each one dragging not just matter, but space itself. Even the idea of space gets twisted. We're inside that twisting. Around us, fragments of light still flicker, ancient photons caught in a doomed orbit, trying to outrun the collapse. You can reach toward them, but they bend away, following the new curves forming around us. The two cause singularities, if such a thing even still applies, are now close. Their surrounding interiors begin to tangle, warping and twisting like strands of thread drawn into a knot. And here's where reality shivers. The laws that told us gravity has direction, that time has order, that cause comes before effect, they begin to unravel, not with noise, not with chaos, but with a quiet, elegant rewriting. You might notice it in small ways first. Memories begin to echo. You feel something before it happens. Your awareness seems to blur at the edges, like it's overlapping with itself. There's a sensation, like hearing a song played forward and backward at once. Emotions arrive out of order. You feel awe before you see the cause. You feel loss before the separation. And then, like a tide pulling back before a wave, everything holds its breath. The singularities meet. But again, this isn't an impact. It's a folding, a joining of places that were never truly separate. Not points, not objects, but events, collapsed histories, tangled timelines, dense beyond imagining. When they meet, the space inside doesn't explode, it transforms. Around us, the very structure of this interior begins to ripple, not outward, inward, like a heartbeat in reverse. The center isn't a point anymore, it's becoming something else. Something that doesn't fit in 3 dimensions. Maybe it's a bridge, maybe a tear, maybe a kind of cosmic womb. Some theories whisper about this, that the merger of 2 black holes doesn't just create a heavier one, but might spawn a whole new region of space-time, a kind of pocket universe, born not in stars, but in shadows. Can you feel it? That stretch? The sense that we're being drawn not deeper, but through. Through what? No one knows. But look, the space around us is starting to glow. Not brightly, not like fire, more like memory, like watching the inside of a dream light up with its own rules. There's color now, but not any color we've seen before. The air, if you can call it that, begins to hum. The sound isn't made of vibration, it's made of meaning. You don't hear it in your ears, you hear it in your understanding. You sense a direction opening up, not forward, not back, something new. And then you realize, we're no longer inside a black hole. We're inside a change. The merger has not just collapsed 2 giants into one, it's redefined the space they contained. Time flows differently here now. It loops, it splits, it doubles back on itself. Space folds inward, then blooms again, fractal and endless. Perhaps this is what it feels like when a universe is born from within another. Could this be how it always happens? Not with fire and noise, but in silence. Within silence, as gravity draws in on itself so deeply that reality must respond, must stretch, must open. And maybe what lies ahead of us now is not just a tunnel through, not just a bridge to another universe, but a place to begin again. Right now, inside this unknowable moment, inside the meeting point of 2 impossibly dense mysteries, we are floating on the edge of an answer no one has ever asked out loud. And it feels like everything is just about to begin. Now you're wondering, what happens if we get out? Let's stay quiet for a moment. Just feel. We've been falling through this collapse for what might be seconds or centuries. Here, time doesn't move in straight lines. It flows sideways, loops, sometimes pauses to look at itself. So getting out doesn't mean going back the way we came. That way is gone, swallowed. But something is ahead of us. You see it too, don't you? That shimmer, that ripple in the dark. It's not light, it's not space, it's potential. Now take a step, not a physical one, just lean forward with your awareness. And suddenly we're through. At first, there's only silence. No sound, no gravity, no stars. Just stillness. Then, slowly, the new world begins to form around us. What we're seeing now isn't the universe we left. It might not even be the same kind of space at all. Remember how we spoke about some theories that black holes could lead to new universes? Maybe we just stepped through the door. The rules here feel different. You can almost taste it. Colors aren't behaving. Gravity doesn't feel like a pull anymore, more like a suggestion. Distances shift when you look at them. That mountain over there, it wasn't there a blink ago. Now it's vast and soft and singing quietly. We're in a place where the fabric of reality is still young, still choosing its shape. This might be what it feels like just after a big bang, before the chaos has settled into stars and galaxies. A kind of cosmic morning. Breathe that in, slowly. Now, look behind you. The black hole is still there, but it's not the same. It looks smaller now, gentle, like a shadow remembering its purpose. It's still spinning, still humming with the memory of collapse. But now it's like an old gate, not a trap, a threshold. You've passed through it. You're on the other side. What's around us now is fresh space, unwritten, new time. Maybe this is a baby universe. Or a side pocket of reality, one that bloomed quietly from the violent meeting of two massive objects we once thought only destroyed. But maybe, creation always hides in destruction. Look up, or whatever up means here. There's something beginning. You see those faint glimmers, those little sparkles forming out of nothing. Those could be the first atoms, the seeds of stars, the beginnings of light. There's no sound, but there's motion. There's intention, like the universe is figuring itself out in real time. And you and I, we're the first to see it. Here, we're no longer just passengers. We're witnesses, observers in a space that's never been seen. Every moment we drift through is one no one has ever lived before. Imagine that, the first sky, the first silence, the first warmth rising from newborn stars. You reach out again, not with hands, with curiosity. The space responds, not with words, but with patterns, with vibration, with meaning, as if this new place is glad to have company, as if it's been waiting. You might feel it, that sense of weightless possibility. We got out, but we didn't return. We arrived. We've left the universe we knew, the stars we watched being born, the galaxies swirling like cosmic pinwheels, the dying suns collapsing into silence. All of that is far behind us now. Behind that dark horizon, we fell through. This is something new. But here's a question that rises quietly, like mist. What kind of place is this, really? We called it a universe, maybe a pocket dimension, maybe a baby cosmos. But those are just names. What we're really floating through is something becoming, something that doesn't yet know what it wants to be. Like a dream halfway between sleep and waking. Reach out. Can you feel it? The air here, if you can call it that, vibrates. Not with sound, but with potential. It's as if the laws of physics are still setting, like soft clay. Some parts feel stable, others shimmer and ripple, not quite fixed. That glow in the far distance, it might be the first light, or it might be something we can't even name. Light that curves inward, light that remembers darkness. And here's something else. We're not the only ones here. Don't worry, we're not in danger, but there's a presence, not a being, not a creature, more like an awareness, the shape of intelligence before it takes form. Maybe it's this space itself learning to think. Maybe when we passed through the black hole, we didn't just escape, we stirred something. Maybe we were the first question this space has ever had to answer. Now let's drift a little further. Just float with me, slow, like a feather on still water. Over there, you see that cluster forming? It's faint now, like embers in fog, but it's gathering. Hydrogen, perhaps. Maybe helium. Raw elements, coming together. You're watching the building blocks of stars, being drawn by nothing more than the gentle tug of gravity, or what gravity will become here. You might notice they move differently than in the old universe. There's a fluidity to their dance, less sharp, as if space here is thicker, softer, almost compassionate. We can't touch anything, but we can feel it in other ways. Let me ask something. What do you think will happen in 1,000,000 years, in this newborn space? Will stars ignite? Will galaxies form? Will time stretch into stories, civilizations, laughter, loss? Could creatures like us rise here someday, peering back through strange skies, wondering how their universe began? Would they ever know that two ancient black holes, monsters of gravity, collided and, instead of ending everything, gave birth to this? Would they ever know we were here, that we saw the very first shimmer of light? Maybe not, but that's okay. Being the witness is enough. Now let's go wider, bigger. This new universe, this hidden pocket of reality born from collapse, is it the only one? What if it isn't? What if every black hole in every galaxy is its own doorway, a seed, a womb? What if, inside each one, A new universe spins out into being, quietly, invisibly, like flowers blooming in the dark. Imagine that. An infinite tree of realities, each black hole, a bud, each universe a branch. The cosmos not as a single space, but as a garden, ever growing, ever folding in on itself and blooming outward again. Life not rare but inevitable. Not lonely, but connected, in ways we can't yet measure. You and I? We were just two stardust travelers who dared to fall too far, and found not an ending, but a doorway. And now, drifting here between what was and what might be, you can feel it too, can't you? That sense of something more. We don't need to name it. Not yet. Let's just float a little longer. Let's listen to this space dream itself into being. And if you'd like, we can keep going. Follow those first elements. See if a star is born. See if light learns to speak. Or we can turn gently, glide along the boundary of this new universe, explore its edge, where reality still bubbles and cracks, and maybe, just maybe, find another door. So, we've watched two black holes collide. We felt the swirl of space-time, the ripple of gravity folding in on itself, the deep and trembling hum of the universe responding. But even after that cosmic meeting, after the flash, the wave, the thunder of silent space, something curious remains. They don't become one immediately. No, it takes time, even for something as unfathomable as black holes. Picture this with me. We're back just outside the event horizon now, floating at a safe distance, cloaked in silence and starlight. In front of us, two black holes have recently collided. You can still see the disturbance in the surrounding space like ripples in a great invisible pond. But there's more than just ripples. The new black hole at the center isn't quiet yet. It's still ringing. Yes, ringing. Not like a bell in the way you'd hear it with ears. This is the ringing of warped space. It pulses out as gravitational waves, waves so subtle that they can travel for billions of years, carrying news of this great merger to distant corners of the universe. Now listen. Can you feel that gentle vibration? That's the ring-down phase. It's the moment after the crash, when the newborn black hole is still quivering, still adjusting, still becoming. It's not perfectly round yet, not quite settled. It wobbles just slightly, smoothing out its shape like a drop of water finally resting after being poured. And here's the fascinating part. This phase doesn't last long by our standards. Once the two black holes collide and merge, the newly formed black hole settles into its final form in just a fraction of a second. Yes, after all that drama, that cosmic dance that took maybe millions or billions of years to draw the black holes together, the final settling, that part takes milliseconds. But let's not rush. Even though the ring down is fast, the journey to that moment can be vast. Two black holes don't just fall together instantly. They begin by orbiting each other, sometimes for eons, slowly spiraling inward, releasing energy in the form of gravitational waves. It's like a long, slow waltz, distant at first, graceful, relentless. Step by step, orbit by orbit, they lose just a little energy each time. The dance tightens. From millions of miles apart to thousands, then hundreds, then just a few. The space between them shrinks until the moment comes, that final, heart-thudding plunge. And then, they touch. They swirl into one, a violent, glorious embrace, and space ripples outward, like the surface of a dark ocean. But even once they've become one, the black hole doesn't stop moving. That final shape, the perfect calm sphere of gravity, takes a little while to appear. That's the settling. That's the ring down. And even though it happens fast, it's measurable. We've actually detected these ripples here on Earth, whispers of black holes long gone, long merged, speaking across the universe. Isn't that astonishing? Think of it. We, tiny creatures on a blue dot in a quiet galaxy, have felt the after-chime of black holes colliding over 1 billion light-years away. And in those tiny vibrations, scientists have read the story, how long the ring down lasted, how massive the final black hole became, and whether it was spinning or still. All from a flicker of gravitational breath. So, to answer you fully, how long does it take for two black holes to fully settle into one? The gravitational ring down after the merger typically lasts just a few milliseconds to a few seconds, depending on their size. But the true answer is more poetic than just numbers. It takes as long as it takes to turn chaos into stillness, to let a violent union become peace, to shape a new silence. Now, as we sit here beside the cooling remnants of that collision, watching the ripples fade into the distance, maybe you're wondering, what happens next? Does this new black hole just sit here forever? Does it grow? Does it sleep? Does it dream? We're floating just beyond the veil of this newly merged black hole calm now, settled into its perfect form after that cosmic embrace. The space around it is smoother, quieter, but there's still a presence, a deep pull that reaches out invisibly. So does it grow after? Yes, it does. But not all at once, and not always in ways you'd expect. Let's lean in, gently, and listen to what the black hole is doing now. It's not just sitting still like a quiet stone in the dark. It's hungry, patiently, endlessly hungry. A black hole grows by feeding, not with teeth or mouths, of course, but by pulling in matter, gas, dust, stars, sometimes even other black holes, anything that gets too close. If there's material nearby, like the leftover remains of stars or clouds of gas stirred up from the recent collision, it might begin to spiral inward, pulled ever closer in a slow, graceful dance. You might notice it a glowing swirl of light forming around the black hole. That's called an accretion disk. It's not the black hole itself glowing, but the stuff falling toward it, getting so hot and compressed it shines. Beautiful, right? Like a golden whirlpool around a dark eye. Let's hover just above the disk. Feel the heat coming off it, soft and far away from here, but still whispering to your skin. Hear the quiet hiss of dust being stripped apart molecule by molecule as it spirals down. Some of that matter will fall straight in. Some might shoot outward in thin glowing jets that stretch for light years. But yes, slowly, over time, this black hole is growing. Each bit of matter that falls in adds to its mass, and as it grows, its gravity deepens. Its pull reaches farther, its shadow stretches wider. And here's something wondrous. The black hole doesn't just grow from what's nearby. Sometimes it moves. Over millions of years, it might drift through the galaxy, pulled by other stars, other black holes. Or if the merger was lopsided, if one black hole was much larger than the other, the new black hole might be kicked by the collision, sent drifting through space like a ghost ship, carrying with it the memory of two lives fused into one. It could wander for billions of years, encountering new matter, slowly feeding, growing larger still. Now, imagine if this is a supermassive black hole, the kind that lives at the heart of a galaxy. After a collision, it might swallow entire star systems. Sometimes, its feeding wakes it up, and it blazes to life as a quasar, shining brighter than entire galaxies for a while, before fading again into silence. And still, it grows. But there's something deeply poetic here too. Even if a black hole stops feeding, if it's drifting in empty space, alone, with no dust, no stars, no light to take in, it still holds everything it's ever consumed. All that mass, all that history, locked within. It doesn't shrink, it just waits. So yes, black holes grow after they merge. They grow when the universe gives them something more. And sometimes, they just wait in the dark, quiet and heavy, until the next opportunity comes. And you know what? From out here, you'd never know what's inside. From a distance, a black hole is just a shadow, a curve in space, a silence with a shape. But you and I, we've been inside one. We've seen the moment of birth. We've touched the spinning heart. So, when we see a black hole growing, we know. It's not just eating, it's becoming. Now for another question. Would it feel warm or cold when black holes collide? Let's start with a feeling. Picture your hand stretched out into the deep dark of space. There's no atmosphere, no breeze, no sound, just silence and stars. Out here, space is incredibly cold, just a few degrees above absolute zero, the kind of cold that doesn't sting, but just quietly takes. But now, imagine we're drifting near two black holes in the moments before they collide, and something's happening. Not inside the black holes, because remember, that's where light and heat can't escape, but around them. As they get closer, the space around them starts to twist and heat. If there's any gas or dust nearby, any leftover material from stars, galaxies, or earlier collisions, it gets caught up in the gravitational dance. That material is pulled and stretched and compressed. And compression means heat. We begin to see a glowing halo form. It's not coming from the black holes themselves, but from the stuff around them being torn apart. That glow can be fiercely hot, millions of degrees in some cases. So if we had the right instruments, we'd see an enormous burst of energy, especially in X-rays and gravitational waves. Let's hover just outside that glow. Can you feel it? The light isn't hitting your skin, because in space, there's no air to carry heat the way it does on Earth. But it would be there, like the warmth of a fire you can't quite touch, radiating, blazing, flickering across the edge of nothing. And when they finally merge, when the black holes actually collide, there's a release, not of light, not in the usual way, but of gravitational energy. It's like space itself shudders. A ripple of pure gravity floods out across the universe. Now here's the beautiful contradiction. The collision is one of the most energetic, violent events in the cosmos, and yet it produces no traditional heat. Because the black holes don't emit warmth from their surfaces. They don't have surfaces. The energy is not in fire or flame, but in motion, in warping space, in collapsing time. So is it warm or cold? It's both. The space around the collision, especially if there's material nearby, can become incredibly hot, glowing with radiation, blazing for brief cosmic moments. But the black holes themselves? Always cold, always silent, like deep water that never remembers sunlight. And even in the heart of that collision, where everything folds in, where two singularities become one that's not a place where temperature makes sense anymore, there, the rules we know break down. Warmth, cold, light, matter, they don't behave in familiar ways. They're all transformed. So maybe we think of it like this. The dance around the black holes is warm, fierce, chaotic, alive. But the final embrace? That's cold, deep, absolute, a stillness beyond heat. And you've been there. Now, you've hovered in that glow. You've felt the pull of darkness and the fire of falling dust. You've listened to the universe hum with energy too deep to see. Let's stay here a little longer. Don't move just yet. Feel how the space around us has changed. We're hovering right at the edge of what was just moments ago one of the most powerful, unthinkable collisions in the universe. And yet, it's quiet now, not silent in a dead way. No. It's the kind of hush that comes after something immense, like standing outside after a thunderstorm, when the clouds have begun to drift and the world feels rinsed and new. Reach out not with your hands, but with your sense of wonder. You might feel the warmth still hanging in the space around us. Not heat like a summer day, not something you'd notice on your skin, but a kind of glow inside your awareness. That's the afterburn of dust and gas that was caught in the pull, shredded and stretched, heated to millions of degrees in a final burst of light before being swallowed whole. It's fading now, drifting outward like smoke curling off dying embers. And beneath that, or maybe within it, something deeper moves. Not light, not sound, but ripples. Gravitational waves. They don't shimmer or glow. They don't brush your cheek like wind. But if we close our eyes and lean into the shape of space itself, we can feel them. Long, smooth tremors rolling outward from the site of the merger, expanding through the universe like the wake of a ship on a dark ocean. And here's what's most amazing. Those ripples might travel forever, past stars being born, past galaxies colliding, past wandering planets and nebulae that never knew they'd been brushed by a whisper of something ancient. And still they go. Now, look at the black hole itself. The new one. You see that perfect curve, that quiet, infinite shadow that doesn't flicker or shift. That's where it happened. Two beings, each older than memory, each heavier than millions of suns, found each other, spent eternity spiraling inward, danced, merged, disappeared, and left this. It looks so simple now, so still, but you and I, we know what it took to become this. The chaos, the heat, the pull of time folding in on itself. Would you believe that inside that horizon, space is still stretching, still reshaping? Even now, the mass is settling into place. The black hole is becoming itself fully, finally, and you're here to see it. Drift a little closer. Feel how the stars bend around it. See how the light from a distant galaxy warps into a soft ring, as if space itself has been twisted like glass. That's what this place does. It remembers everything it's touched, everything it's swallowed. And in some strange way, so do we. Now take a moment. Just breathe. The universe is vast, but here, in this one moment, we are exactly where we need to be. We're hovering near this freshly formed black hole, right after two giants have collided and become one. And even though it's quiet now, there's a wild richness to the moment, a kind of cosmic memory woven into the very shape of space. Now here's something deeply real. When two black holes merge, up to a few % of their total mass is converted into gravitational waves. That may not sound like much, but consider this. If you had two black holes, each maybe 30 times the mass of our sun, just a few suns worth of that mass vanishes not into the new black hole, but into pure energy, rippling through the fabric of space. That's more power than all the stars in the observable universe emit combined in that same instant. And yet, unless you're incredibly close, you'd never feel it. Let that sink in. We're right beside something so powerful it makes galaxies shiver, and yet space around us looks calm, almost peaceful. That's one of the strange beauties of black holes. They wear their power in silence. Now, look around. We're in intergalactic space, way beyond the arms of any familiar spiral galaxy. The stars are sparse here. The darkness feels heavier. But even in this emptiness, black holes change everything. See that faint cloud of light to our left? That's matter that didn't quite make it into the event horizon. It's glowing not because of magic, but because of friction and pressure. That gas is falling inward, spinning faster, heating up, sometimes forming jets that shoot out from the poles of the black hole, narrow beams of pure energy, stretching across thousands of light years. Imagine watching one of those jets emerge, lit like a lighthouse against the dark. And now here's another truth. Black holes can spin. Some of them spin slowly, and some, especially ones born from massive collisions, spin almost at the speed of light. We're close enough to sense it. Look at how space itself seems to drag around it. That's called frame dragging. Time bends differently here. If you were to orbit this spinning black hole closely, your clock would tick slower than someone floating far away. You'd age slower. Days could pass out here, while only minutes pass for you. Wild, isn't it? And still, all this complexity, all this physics, happens in silence. Black holes don't roar. They don't flash. They pull, they bend, they curve, they erase, and they leave behind clues. You and I, we've become witnesses now, quiet watchers at the edge of gravity's final trick. And here's something that might stir your curiosity even more. The black hole we're beside, it won't stop growing. Even after the grand merger, it's still reaching. Over billions of years it might swallow stars, drift into galactic centers, or even collide again with yet another black hole. There are no endings here, just transformations. Now close your eyes again just for a second. Feel how space warps inward, like a gentle slope beneath your feet. You don't fall unless you step too close, but the pull is always there, the invitation to go deeper. Want to know another strange fact? If you were to fall into this black hole, you wouldn't notice the moment you cross the event horizon. There's no signpost, no flash. You'd just float through, and suddenly escape becomes impossible. From the outside, it would look like you froze in time, stretched thin, fading to darkness. But you inside would keep falling, drawn toward a place where time and space lose meaning. And here's where fact and wonder meet. No one truly knows what happens at the core. Not scientists, not theories, not even the math agrees. Some say there's a single point of infinite density, a singularity. Others believe quantum effects rewrite the rules before you ever get there. Some whisper of wormholes or bridges to other universes. We just don't know. And maybe that's why it's so powerful to be here, beside it, with you. Because black holes don't just challenge physics, they challenge imagination. They hold the edge of what we can know, the place where mystery still rules. And maybe that's why we come back. To drift near the silence, to listen for the truths that haven't been spoken yet. We've been floating near black holes like curious stargazers, watching from a safe distance as they spiral, collide, merge, and grow. But now, let's bring it closer to home. Let's ask gently, how close would a black hole have to be for us tiny humans, spinning on our little blue planet to actually feel its presence? Well, take a deep breath. You're safe, because black holes are far, far away. But let's drift through this idea anyway, together. First, imagine we've returned to Earth's orbit, you and I, just floating above the curved horizon, watching sunlight glaze over oceans and mountain peaks. It's peaceful here, familiar. Gravity feels gentle. Time moves steadily. Now, picture a black dot on the edge of the sky. A black hole, drifting silently toward our solar system. What would happen? If it were small, say, a black hole with the mass of our sun, it would need to be very close before we felt anything unusual. And by close, I mean closer than Pluto. Actually, inside the outer planets. That kind of black hole could pass quietly through the outer solar system without us even noticing unless it got closer. But if it wandered into the region near Jupiter or Saturn, now we're talking, their orbits would wobble. Gravitational tugs would start shifting planets slightly. Over time, the inner solar system might become unstable. And if it came even closer, say, near Earth's orbit, well, things would get wild. Not instantly, though. That's the creepy part. At first, it wouldn't look like much. Maybe a few odd asteroid movements. Satellites might drift a bit off course. Tides might shift just a little. But then, planets would begin to pull away from their usual paths. Orbits would stretch, warp, or collapse entirely. And eventually, the Earth itself might get flung from the sun or pulled inward toward the intruding black hole, depending on how massive and fast it was. Let's drift even closer with this thought just for a moment. If a stellar mass black hole passed as close as the Moon, Earth would experience gravity like never before. Mountains might shift. Oceans would surge. Our planet's crust could quake from the uneven pull. And if it passed closer than the International Space Station, well, Earth might not survive that. The tidal forces could tear the planet apart, not with fire, but with silent gravity. You wouldn't feel heat. You wouldn't hear explosions. You'd just feel the world, stretching. Now, before we go too far into that eerie picture, let's step back. There's good news. Space is huge. Incredibly, impossibly huge. Even though there are likely millions of black holes in our galaxy, they are spread far apart. The odds of one passing anywhere near us, let alone close enough to cause harm, are astronomically low. We've never detected one that even comes close to threatening Earth. And even when two black holes collide and send out gravitational waves, the waves that eventually reach Earth are so faint, so stretched, they pass right through us without a trace. The detectors that find them, like LIGO measure, changes smaller than a proton's width. That's how subtle the effect is at this distance. So, yes, if a black hole were close, truly close, we'd feel it. The tides would rise. The sky might shift. Even time would begin to move differently. But in truth, we are so far from all of them that we're safe, for now, in this gentle pocket of space. Still, you and I know now, don't we? What lies beyond? What could happen? So let's float just a bit farther, with that knowledge tucked softly into our minds, like stardust in our pockets. The black holes aren't coming for us, but if one ever did, we'd feel it before we saw it, and the universe would never be quite the same. What would happen to us, to humans, after two black holes collide? Let's step back into the quiet, into the cold hush of space. You and I, watching from a safe distance again, out where the stars don't twinkle, where sound doesn't travel, and where time stretches like taffy. There, see it? Two black holes, massive beyond reason, spiral toward one another. They twist space like cloth, dragging light, matter, and time along with them. And then, they merge. An invisible flash, no light, but a ripple. A massive wave moves through the universe, a gravitational sigh heading out in every direction. And Earth? Still orbiting the same little star, still spinning under its blue sky. Because here's the strange part. For most people, nothing would happen at all. That's right. If two black holes collided light years away, even if they were supermassive, even if they bent space itself, humans wouldn't feel a thing. No quake, no flash, no shaking skies or flickering sun. The gravitational waves would reach us, but they'd be unimaginably faint. They would pass right through us, through the ground, through our cities, our oceans, our own cells without a trace. Only the most sensitive detectors on Earth would even notice. That's the mystery of it. A universe-shaking event can happen, and no one notices. But let's imagine something different. Let's say we weren't far away. Let's say Earth was a little too close to the black hole merger. Not inside it, that's a different fate entirely, but just nearby enough. What happens then? First, the light show. Matter falling into the black holes before the merger can form vast, swirling disks of superheated gas. These can blaze brighter than galaxies, especially if the black holes are surrounded by stars and dust. It would look like a second sun had been born, huge, angry, and pulsing with power. Then the waves. Not sound waves, not light waves, but gravity itself, shaking space. If we were close enough, those waves could have real effects. Satellites might fall out of orbit. Tectonic plates could shudder. Oceans might slosh in strange patterns. Power grids could flicker not from a storm in the sky, but from a ripple in space-time. And time. Oh, time might get strange. Because near the collision, time would slow down for anything caught in that warped space. From far away, someone watching Earth might see us moving in slow motion. But for us, life would feel normal, just a little off. Clocks wouldn't tick the same. GPS wouldn't work right. Your heartbeat might not line up with your own watch anymore. And long term, if the newly merged black hole drifted into our neighborhood, Earth's orbit could wobble. The sun could be tugged. Planets might drift out of alignment, pulled into new paths. In the worst-case scenario, and we're talking very close, Earth could be pulled slowly, unavoidably, into that dark maw. It wouldn't be fiery. It wouldn't be loud. We wouldn't even feel falling. Just a long stretch of twilight. A strange, creeping cold. And the soft unraveling of time itself. But again, let's be clear, this is imagination. In truth, most black hole collisions are so far away that we'll never feel them. They are like thunderclaps we only see by watching the ripples in a pond, faint and delayed. And so, after a black hole collision, for humans, most of the time nothing at all, except the knowledge that it happened. That somewhere in the dark, gravity danced with itself and made a new shadow in the sky. And that's the real magic, isn't it? We're here, tiny, fragile, curious creatures, on a little world, orbiting an average star. And yet, we can know these things. We can watch space tremble. We can feel awe from billions of miles away. So no, we wouldn't vanish. Not from a distant black hole kiss. But we'd remember. We'd listen for more. We'd wonder. And maybe we'd feel just a little more connected to the vast and silent beauty waiting beyond our sky. Let's lean in together for this one close, very close, and ask the universe softly, what would it sound like when two black holes merge? Of course, space doesn't carry sound the way air does. Out here, there's no wind to rustle, no air to shake, no thunder to echo off canyon walls. But that doesn't mean black holes are silent. No, they sing, just not in ways our ears were built to hear. But still we can translate those songs. We've built instruments, like LIGO and Virgo, that don't use microphones, but instead measure the smallest, most delicate trembling of space itself. When two black holes spiral together and finally crash into one another, they send out a ripple, a gravitational wave, and that ripple passes right through everything. So let's bring that wave into human hearing. Let's take what the detectors feel and shift it, lower it, stretch it until it reaches a pitch our ears can understand. Are you ready? It's not a roar, not a crash, not even a cosmic boom. It's a chirp. Yes, a chirp. A soft, rising whoop sound that grows higher and faster until it stops suddenly and all is quiet again. Let's imagine it now. Float here in stillness with me. You close your eyes. Feel the emptiness around you. And then, woo-oo-oob. Silence. That's it. That's the song of two black holes colliding. It might sound almost comical, like a bird call in a forest, but it's anything but. That sound you just imagined? It represents the moment when millions, even billions of times the mass of our sun spiraled together and vanished into a single, darker hole in the universe. The rising pitch is the orbit tightening. The quickening tone is the final spin. And the sudden cutoff is the moment of union when there's no longer two but one. And sometimes, if you listen closely to the end in recordings from real data, there's a faint quiver, a dying ring, like a bell, just struck once, and then fading forever into quiet. Now think of this. Those tiny chirps we hear, those playful little waves, are from collisions that happened 1 billion years ago, farther away than we can truly imagine. The sound was born in a place we've never seen, from objects that no longer exist as they once were. But the song still found us, and there's something heartbreakingly beautiful about that. Like hearing a single note from a forgotten piano, echoing down a long corridor, or the way a message in a bottle might wash ashore centuries after it was written. Black holes don't speak in words. They don't flash like fireworks, but they sing in curves and ripples and gravity. And we, soft little humans on a small planet, have learned how to listen. That's magic. That's science and poetry braided into one quiet moment. So the next time you're lying awake, staring at the ceiling, listening to the stillness, imagine that gentle chirp passing through you. It probably is. Right now, you don't feel it, but space does. And your atoms? They remember. So here we are, drifting in the slow orbit around something that was once two and is now one. The new black hole doesn't speak, but it radiates presence, not through light, but through the shape of space itself. You might not see it do anything, but everything around it behaves differently because it's there. The stars keep their distance. Gas clouds spin like dancers unsure whether to approach. Even time itself seems a little uncertain, like it's holding its breath. And if we hover long enough days, centuries, millennia, we'd notice how this black hole becomes a fixture in the galaxy, a gravitational anchor, a reference point in a universe that rarely offers anything permanent. You and I are witnessing something most eyes will never see, the calm after the most violent event in the universe. No flames, no smoke, just gravity settling in like dust after a storm. And even though it's done growing for now, the story's not quite over. Over time, this black hole might catch stray stars. It might tug on a passing nebula and feed on its gases. Every meal adds a bit more weight, a bit more pull, like a slow heartbeat continuing on in the dark. Eventually, galaxies around it might change course because of it. New stars may form in its wake. Whole star systems might be thrown off balance just because of its invisible presence. All this from something that no longer moves, not like before. And yet, it influences everything. It's strange to think, isn't it? That something so quiet, so dark, could shape so much. But maybe that's what black holes teach us. That not all power is loud, not all endings are final, and not all mysteries need answers to be beautiful. So let's stay a little longer. Feel the gravity. Watch the stars circle. Thanks for floating with me this far, truly. We've followed black holes through the wildest corners of space, from the moment they first felt each other's pull, to the slow spiral inward, to that final breathtaking collision. And now here we are, quiet, watching the aftermath, you and me, side by side in the stillness of deep time. And what a stillness it is. There's no chaos now, no blinding light, no roaring force, just the gentle hush of space, the new black hole resting like a sleeping giant in the heart of its galaxy. Let's imagine we've set up a little observation perch out here. Maybe it's a kind of cosmic balcony. No wind, no noise. Just stars above, and galaxies scattered all around, like glitter spilled across a velvet sky. We're wrapped in the kind of silence that makes your own heartbeat sound loud. And yet, that silence is rich, full of stories, full of weight. Look out past the horizon of this newborn black hole. You might notice how the stars curve oddly as we pass them. Their light bends, just a little, not because of tricks or illusions, but because space itself is bent. The black hole doesn't just sit there, it reshapes the landscape of the universe around it, not in a violent way anymore, but in a kind of invisible, ever-present tug. Now picture this. Over time, this black hole may drift toward the center of its galaxy, becoming the very core around which everything else slowly rotates. Like a conductor with no baton, no movement, and yet somehow keeping the entire cosmic orchestra in motion. And what happens next? Well, it might grow. It may not be in a rush, but black holes are patient feeders. When a stray star wanders too close, maybe pushed by another star's gravity, or slowly tugged over millions of years, it will spiral in. You and I, watching from a safe distance, would see a swirl of glowing matter form around the black hole like a whirlpool of light. That's called an accretion disk, a bright, hot ring of material whipping around the event horizon just before falling in. It glows with intense energy. Some of it escapes as X-rays or powerful bursts of radiation. If we had the right instruments, we could hear those frequencies, not with ears, but with detectors tuned to the secret sounds of space. And then, silence again. That star? Gone. Folded into the black hole's mass. Its story, now part of something larger. This cycle can happen again and again. One star after another. A wandering cloud. A collapsing cluster. All of it drawn in slowly, inevitably. And yet it's not destruction for the sake of it. It's more like transformation. These things don't just vanish, their energy becomes part of the black hole's story. Their mass, their gravity, their motion all folded into this new creature of the universe. Now imagine this new black hole after trillions of years. The galaxy around it is fading. The stars are burning out. One by one, the bright pinpricks that once filled the sky begin to go dark. Even red dwarfs, the longest-lasting stars, are growing cold. And what's left? Us, floating here still. The black hole, and the memory of everything it once absorbed. Now, picture the sky after all the stars have gone quiet. It's not completely black, not yet. There's a soft glow in the distance, a whisper of light left over from ancient galaxies, scattered across the last glimmers of the universe. A few white dwarfs still smolder, like forgotten embers in a vast fireplace. Some planets may still orbit them, dark and cold, long stripped of warmth. But here at the center of what was once a galaxy, maybe even many galaxies, now merged, our black hole still sits, vast and unchanged, larger than ever, older than almost everything. Time has become stretched, slower. Distances feel even vaster now that there's so little motion to measure them by. We float in close, not afraid. You can feel the pull, but you're not falling. We're observing calmly, from just outside the event horizon, a place where space slows to a crawl and time leans toward forever. The black hole doesn't speak, but it is speaking, in a way. It radiates meaning through its gravity. It holds within it all the motion it's stolen. It is dense with stories, with stars, with history, and even now, it's not entirely alone. There's background radiation everywhere, the faint hum of the Big Bang itself, cooled and stretched until it's just a murmur. Every so often, a photon from that ancient fire might skim the black hole's edge, curling into its horizon. Does it notice? Does it remember the beginning? We can only wonder. Let's settle on a small ledge of time here, just you and me, watching the slow, quiet aging of the cosmos. A black hole like this one doesn't grow tired. It doesn't rust. It doesn't age in the human sense. But eventually, even this giant will begin to let go of its grip. How? Through something that might surprise you. Heat. Yes, the coldest, darkest object in the universe leaks warmth. Very, very slowly. It's called Hawking radiation, the idea that, over unthinkably long stretches of time, a black hole will evaporate, bit by bit, particle by particle. It's not like steam rising off water. It's more like a whisper, a single molecule escaping through a stone wall, once every billion years. But time is patient, and given long enough, even giants fall. So, after more years than there are grains of sand on all the beaches of Earth, this black hole will shrink, its edges will soften, the event horizon will begin to contract inward, still silent, still slow, still unthinkably powerful but beginning to fade. We can stay here for a while, through this long goodbye. It won't hurt us. We're just observers now, companions to a fading colossus. At first, you'll barely notice the change. But then, a flicker, not of light of loss. A piece is gone, then another, until, finally, after a lifespan longer than the universe itself, pop. Not an explosion, not a collapse, just Absence. The black hole is no longer here. All the mass, all the gravity, all the memory return to the void in the quietest way possible. And that, my friend, is the end of the black hole. Not in fire, not in fury, but in the softest fading you could imagine. But don't feel sad. This is how the universe lets go. It doesn't panic, it doesn't cling, it simply releases. And we're still here, floating in the calm that follows. This place, it feels like the universe has exhaled. No rushing stars, no screaming jets of plasma, no tumbling matter, just stillness, the kind that makes your chest feel heavy, but not in a bad way. Heavy like a thick blanket on a winter night, heavy like meaning. We've come a long way, haven't we? Past the swirling arms of galaxies, past the spirals of time, past black holes crashing together like slow, deliberate thunder, and now we're sitting in the hush after it all. This black hole before us, it's not new anymore. It's settled in, quiet and sure of itself, holding all the weight of 2 lives and more. It doesn't glow, it doesn't roar, but it is, and that's enough. Lean in, just a little. You feel that? The faint tug, like being remembered by something too big to speak. This gravity isn't violent anymore. It's gentle, like a hand on your shoulder in the dark, reassuring, certain. The space around it isn't empty. No, it's brimming with memory. Each photon it bent, each star it swallowed, each orbit that ever danced around its rim, they're here, folded into its mass, woven into its silence. You don't need to see them to know they're part of it now. And still, the universe waits. All around us, galaxies drift like lanterns in an ocean of time, fewer than before, dimmer, softer, but still floating. There's a comfort in that, I think. Not everything burns out all at once. Some things just get quieter. You can almost imagine this black hole, now fully grown, not just resting but listening to the echoes of its past, to the tiny final embers of the stars that made it. And maybe it dreams. Not the way we do, with thoughts and pictures, but with gravity, with time, with the endless, wordless pull that brought it together in the first place. So what happens now? Well, nothing, and everything. It will sit here, patient, unblinking, while galaxies slip away one by one, while space stretches, while time thins, until one day, even the black hole itself begins to fade, not loudly, not suddenly, just a long sigh, a last breath, a final flicker. And when it goes, there won't be a bang. No fire, no ash, just a soft absence where something impossibly large used to be. And yet strangely you won't feel alone, because the universe has always carried its endings gently, wrapped in mystery, swaddled in stillness, left like footprints in snow, fading slowly under a quiet sky. So we'll drift. No need to hurry. We've seen the dance of giants. We've stood at the edge of time. We've listened to the breath of gravity and watched light curve like silk across the void. This story doesn't need a bow. It just needs a moment like this, where you pause, breathe in, and understand. The universe doesn't shout its secrets. It whispers them, just loud enough for those willing to float a little longer and listen. You heard it. Thank you for being here. Until the next journey, stay curious and stay quiet enough to feel the stars.